Here is something that will genuinely mess with how you see reality. Scientists can tell you exactly how fast an electron is moving, or they can tell you exactly where it is, but they can never tell you both at the same time. Not because our tools aren't good enough, not because we haven't figured it out yet, but because the universe itself forbids it. This is the Heisenberg Uncertainty Principle, and once you understand it, you will never think about reality the same way again. Let's start with everyday life. If your friend is driving down the street, you can look out the window and know exactly where their car is right now. Or you can check the speed on GPS. In theory, you could know both simultaneously, location and speed. No problem. That's how the world works at human scale. Now, shrink everything down to the size of a single electron. Suddenly, that logic completely breaks down. An electron doesn't have a precise position and a precise momentum at the same time. It's not hiding that information from us. It genuinely does not possess both properties simultaneously. This is what Werner Heisenberg discovered in 1927, and it broke physics. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. These two properties are fundamentally linked, like opposite ends of a seesaw. Push one down, the other goes up. And here is something crucial. This is not the observer effect. Even with a theoretically perfect measuring device, one that disturbs absolutely nothing, the uncertainty would still be there. It's not about the measurement, it's about the nature of the particle itself. To understand why, we need to talk about waves. In quantum mechanics, every particle has a wave like nature. They are not little balls flying through space, they are more like ripples. Think of it like a song. A song exists across time. It has rhythm, melody, frequency. If you freeze a song at a single instant, you lose the melody entirely. But if you let it play out fully, you can't pin it to one specific moment. Particles work the same way. A particle with a very precise position looks like an extremely sharp, narrow wave spike. But that spike is built from many different wavelengths overlapping, so its momentum becomes completely smeared out. On the flip side, a particle with a very precise momentum has a single clean wavelength, but that wave stretches out across space, so its position becomes completely undefined. You cannot construct a wave that is both perfectly sharp in location and perfectly defined in frequency at the same time. The math forbids it. This comes from a branch of mathematics called Fourier analysis. So, the uncertainty principle is woven into the mathematical structure of waves themselves. Now, here is where it gets personal. Einstein, the most celebrated scientist of the 20th century, absolutely refused to accept this. He believed there had to be hidden variables, secret information particles carry that we just hadn't found yet. He famously pushed back, God does not play dice with the universe. For years, this was one of the greatest intellectual battles in the history of science. And today, the evidence firmly supports the uncertainty principle. Decades of increasingly precise experiments have confirmed it again and again. The uncertainty isn't a gap in our knowledge, it is a fundamental property of reality. You cannot know a particle is and how fast it's moving at the same time, not because physics hasn't advanced far enough, but because the universe at its deepest level is fundamentally uncertain. Einstein spent his life fighting this idea. The universe didn't budge. And maybe that's the most profound thing about the Heisenberg uncertainty principle. It is not a flaw in our understanding of nature. It is the nature. If this video made your brain do something wild, subscribe because there's so much more where this came from. And drop your answer in the comments. I genuinely read everyone. Does it feel more unsettling or more beautiful to you that reality has a built in blur? Because either answer says something really interesting about how you see the world.